Okay, so today's video is talking about prime factorization. Before we actually work this question out, where we're getting the prime factorization of 90, let's go over the word prime and also the word factor, so that way we won't be confused on what we're looking for. Alright, so prime factorization. So when it comes to prime numbers, you need to remember that prime numbers only have two factors. Alright, just two factors. And an example of a factor is when you get two numbers and you multiply them to get that number. Let me get a multiplication chart to help me explain it better. So here's a multiplication chart. This is going to help me show you what a factor is. So you can get pretty much any number around here. And let's just do this randomly there. Bam. 16. So when they're mentioning factors, it is two numbers that when you multiply to get you that number. So right here, one of the factors is 4. Alright. Is that the only factor 16 has? No, if you look around, you'll find it somewhere else where you see more factors. Like right there. So that means that 2 and 8 are also factors. Again, factors are two numbers that when you multiply to get that number. Alright. So the examples of factors for 16 would be 2, 4, and 8. And there's also another 2 that have not listed here. Alright. The examples would be 1 and itself, which would be 16. So let's write all the factors for 16. So 16, that when you multiply 4 times 4, alright, that gives you 16. Well, you know what, let's write it differently so you won't be confused. It's the same thing. This and this are the same. I got that from here and here, in case you're wondering. Another example would be 8 times 2. 8 times 2, that gives me also 16. And one more set of numbers that also give you 16 are going to be 1 and 16 give you 16. So how many total factors for 16? Well, let's count them up. You got 1, 2, 3, 4, 5. You're not going to count 4 twice, okay? So just count it once. So it's got a total of 5 factors. So this would not be a prime number. A prime number only has 2 factors. Again, prime numbers only have 2 factors. Oops. This one has 1, 2, 3, 4, 5. So it's not a prime number. So what is it called then? Anything that is not a prime number, that is not a prime, alright, is called composite. So if it's not prime, it's called composite. That means it has 3 or more factors. Alright, that's what you call composite. Prime only has 2. Composite has 3 or more. So for example, 16 is a composite because it has 5. Does it have 3? No, but it has more than 3, so that makes it composite. So make sure you know the difference between a composite number and a prime number. So what are some examples of prime numbers? Well, let's go back over here. Alright. If you look to the left, you'll see a chart that goes all the way to 100. Anything that's highlighted green is, guess what? A prime number. And let me prove it. Let's get one of these numbers. Let's get 13. So 13. What two numbers can I multiply to give me 13? Well, there's 1 and 13. 1 times 13 gives you 13, so that's true. Is there any other examples where there's two different numbers that give me 13? You know what? I can't think of any. It's just those two. So that's what makes it a prime number. Prime numbers only have two factors. The factors are 1 and itself. All right? 1 and the same exact number, 13. Let me give you another example. It only has two factors. So let's pick any other number that's green, should work. Let's go with 37. All right, so what two numbers that when I multiply give me 37? 1 and 37. Is there any other two numbers where I multiply to get 37? Like, can I multiply 2 times something to give me 37? Nope. Can I multiply 6 times something to give me 37? Nope. There is nothing. It's only these two. That's why it's a prime number. It only has two factors, 1 and itself. Okay, so we know what prime numbers are and what factors are. Again, factors are numbers you multiply to get that number. So for example, the factor of 20 would be 4 and 5. 4 times 5 give me 20. The factors of 20 are 4 and 5. And we talked about prime numbers. Prime numbers only have two factors, and that's it. If you forget, all these in green are factors. So let's try to solve an example of getting prime factorization. When I say prime factorization, that means I'm going to get all the factors of 90, but only in prime form. So let's use this to help me out. This is going to remind me of what is a prime number and what is not. And by the way, what do you call a number that's not a prime number again? It is called composite. Again, if it's not prime, it is called composite. All right, but we're actually looking for the prime, so don't worry about that word. But remember, if it's not prime, it's called composite. So all these then white that you see here, every single number in white is not prime. So that means every single number in white here is composite. Everything else, which is green, is prime. All right, so we got those definitions out of the way. Let's get started with 90. The way to solve this is by making a factor tree. All right? At the end of all this, it's going to look like a tree. Okay, in case you're wondering. All right, get you in the Christmas spirit. So, if the number is composite, it will receive two branches. Again, if it's composite, it gets two branches, guys. What you're going to put for each of these branches is going to give me two factors to give me that number 90. So what two numbers that you multiply that give you 90? Well, there's 3 and 30. So then you would put right here 3 and 30. Or you can also put, let's go with 45 times 2. That also gives you 90. So right here, you could put 45 times 2. You can also put, let's look for another example, 18 times 5. That also gives you 90. So here you can also put 18 times 5. And let's do one more. Another example would be 9 times 10 to give you 90. So right here you would put 9 and 10. All these combinations will work and give you the right answer. So you can use 9 and 10 here, or you can use 18 and 5 here, 45 over 2, or 3 and 30. I'm going to go with the last one I wrote, 9 and 10. Remember, it's getting two branches because it's composite, and then you got to list the two numbers to multiply to get that number. We continue with the tree. The tree does not stop growing or branching out until you only have prime numbers left. 9 is not a prime number. It gets two branches. Same thing with 10. It is also not a prime number. It's composite, so it also gets two branches. And what we're going to do for 9 is the same thing we did for 90. I got to think of two factors I got to put here that give me 9. All right? So the factors for 9 would be 3 times 3. And the only other factors would be 1 times 9. Now let me give you a heads up when it comes to factor tree. When you're making your factor tree or getting the prime factorization, you can never use 1 as one of the numbers. That does not count. Again, 1 is not allowed in your factor tree. So this combination will not work. It's not acceptable. Any other number other than 1 is okay. So my only choice here would be 3 and 3. And now I can do the same thing to 10. What two numbers that when I multiply give me 10? Well, there's 2 times 5, that gives me 10. And also 1 times 10, that gives me 10. But again, if it has 1, you cannot use that in your factor tree here. That is not allowed. So this is off limits. I have to use this one instead. So you're going to multiply 2 times 5 to give you 10. If you notice, this is prime, that's prime, that's prime, that's prime. When all the numbers are prime, that's when your tree stops growing. So I stop with the tree, but I'm not done yet with my work. What I'm going to do next is put my numbers in order from small to big. So 2, scratch it off, times 3, scratch it off, times 3, times 5. I just listed all my numbers in order from small to big. 2, 3, 3, 5. And one more thing, exponents. In 6th grade, they usually want your answer in exponential form. What that means is, instead of writing, real quick, 4 to the power of 3, okay, that's what this 3 stands for, to the power of. What does that mean? Well, that's your exponent. That's letting you know how many times, okay, this is letting you know how many times you're going to be using this number, which is called your base, to multiply. It does not mean 4 times 3. Again, it does not mean this. That is wrong. What it means is you're going to use the number 4. Oops. You're going to use the number 4 3 times by multiplying. Again. All right. I used it 1, 2, 3 times. That's what 4 to the power of 3 stands for. That's how exponents work. I'm talking about this one right here. So instead of writing 3 times 3, using exponents, I could put 3 to the power of 2. Remember, this number tells me how many times I used that number. I used it 1, 2 times by multiplying. That's where I got that number. So that's how exponents work. Everything else that's not expressed by exponents, you bring it down. So the 2, you bring this down. You also bring that down. And now you're officially done. So what is a prime factorization of 90? It would be 2 times 3 to the power of 2 times 5. That's my answer.